Okay, Algebra 2 students, this is the review for Test 2.1. This is linear inequalities and systems of equations and inequalities. And I'm going to only select a few of the problems off of our review sheet for this video. So make sure you pay close attention to these particular problems, but also the ones that we go over in class. And of course, if you have any further questions, then you need to attend tutorials. We're going to start with question number 2 on the review. This is a system of linear equations, and we're going to solve the system by graphing. And also I want to talk about how you find the point and how you can tell whether a point is a solution or not. So there's actually two different ways that we can graph these equations together. One of the ways is to use the x and y intercepts, and the other way is to use the slope-intercept form of the linear equation. So I think with this particular problem, it may be easier to just use the x and y intercepts, but we'll do it both ways. All right, so if I'm using the x and y intercepts, if I make x 0 and I solve for y, I get negative y equals 8. So if I'm solving for y, I'm going to get y equals a negative 8. So that would be my my y-intercept, negative 8. And then if I'm using the same method and I make y 0, then x equals 8. So then my line goes through those 2 points. So that's one way to do it. The other way is to go ahead and put it in slope-intercept form, which would give me negative y equals negative x plus 8. And then divide everything by negative 1, and I get y equals x minus 8. So again, I've got my y-intercept is at negative 8, which is right here. This is my negative 8. And then my slope is 1, so you can see that the graph has a slope of 1. So those are the two methods that you can use. So what you want to do is you want to look at these equations to see, well, is it easier just to put it in slope-intercept form, or is it easier to use the x and y intercepts? So whichever way you decide to do it, it's fine. It doesn't matter to me as long as the line that you create on the graph is correct. This one I'm going to go ahead and solve, and I'm going to solve for y, put it in slope-intercept form. Okay, so as you can see, I've put this in slope-intercept form. I subtracted 2x from both sides, and then I divided by 3, and I got negative 2/3 x plus 7. So this other line that I'm going to draw is going to have a y-intercept of 7 and a slope of negative 2/3. That means I'm going to go down 2 and to the right 3. Down 2 to the right 3. And I'm going to keep doing that until I find my point of intersection, which is going to be right here. All right, so a couple things I want to talk about this point. I noticed on the homework that a lot of you are not writing your answer as an ordered pair. And this is very important because you need to understand that the solution for a system of equations in this case is going to be a point on the graph. You're going to have an x value, in this case 9, and a y value, in this case 1. This is your solution. So if you just write x equals 9 somewhere on your page and then y equals 1 somewhere on your page, yeah, that's true. Those are the x and y values of the solution, but the actual solution is a point. And you should write your answer as a point. So make sure that you do that on the test, because if you just give me that x equals this and y equals that and you don't write it as an ordered pair, then you might end up losing points. You really need to understand that that point is the solution to this system. So if I take that point and I plug it back in to my two equations, I should get a statement that's true. So if I make x 9 and I make y 1, I should get 8. And indeed, I do get 8. So you always also want to check and make sure that your solutions actually are solutions. Okay? So 2 times 9 is 18, plus 3 times 1 is 3, and 18 plus 3 is 21. So that one also checks. So just make sure that you know what solution means, that you write it as an ordered pair, and that you plug it back into the equations and make sure that that point makes those statements true. If it doesn't, then you've got the wrong point. So just make sure you double check everything. All right, so I'm going to skip over to question 7, and we're going to solve this system by substitution. So the first thing I want to do is I want to look for an x or y variable that's already by itself and without any coefficients in front of it except 1. So that would be this one right here. Oops. Okay, so if I solve for that y, then I will have something that I can substitute into my other equation. And this is just like the function composition we did last 6 weeks. So this should be something that you're quite familiar with. So if I solve for y, I get y equals 2x minus 12. And now I can take that 2x minus 12 and I can substitute it in here into the y in my other equation. Okay, so I have solved for y. I substituted this 2x minus 12 in for y in the second equation. I simplified this by combining the negative 7 with the 2x minus 12. I distributed this negative 7 through. Be very careful with all these negatives. You see all these negatives? Be very careful with that. So negative 7 times 2x is negative 14x, and negative 7 times a negative 12 is a positive 84. Now I combine like terms, and when I add a negative 7 with a negative 14, I get a negative 21. Plus 84 equals 21. And then I subtracted 84 from both sides, and I got negative 21x equals a negative 63. Then all I had to do is divide both sides by negative 21, and I got x equals 3. Now I'm not finished yet. Remember I said the solution is a point. I only have part of my solution. I only have the x part. I need to get the y part. Okay, so this part of my solution is 3. And I still need to find y. Well, I can substitute 3. I can substitute the 3 in right here. Okay, I can substitute it in here and solve. Anywhere I want to, I can substitute this negative 3. Since I know x is 3, I can substitute this, not negative 3, it's 3. I can substitute this 3 in wherever there's an x. So I'm just going to go ahead and substitute it in here since I already solved for y. So I'm going to substitute that in, and I'm going to say that y is equal to 2 times 3 minus 12. Well, that's just 6. So y equals 6 minus 12, and that's going to give me y equals negative 6. So my y value is negative 6. Now this is my solution. So if I want to know if a point is a solution to a system, I can just plug it in. So I always want to check my work and plug them back in and make sure that what I think is my point is my solution really is my solution. So you plug it back in. And I say, okay, well, negative 2 times 3. Negative 2 times 3 is negative 6. Negative 6 plus a negative 6 is negative 12. So I know that one checks. Okay? But I have to check the other equation too. They both have to work. So I plug a 3 in right here for my x, and I get negative 21, and then I plug a negative 6 in for the y, and I get a positive 42. So a negative 21 plus 42 is 21, so that works as well. So I know that my solution, 3, negative 6, is the solution for this system. So I'm going to emphasize this one more time. You can check any point to see that if it's a solution or not by plugging it back in to the original equations and check. Please do that on the test. Okay, for this next problem, we're going to go to problem number 9. And instead of using any method, because any method means you could use your calculator, and this problem on the test is asking you to use a specific method, and that specific method is elimination. So we're going to use elimination for this problem instead of any method. It's real important to make sure that you follow the instructions on the test, because if it asks you to use a certain method, then that's the method you have to use. And if you use the wrong method, you lose a lot of points. So it's important to make sure that you are using the correct method. Now with elimination, we're just adding the equations together and eliminating one of the variables. So the first thing we want to do is make sure that our equations are in the right form. We want it to be an ax plus by equals c form. And then we're going to line those variables up, and we're going to see if we can eliminate either the x or the y. So I'm going to go ahead and line these up. I'm going to move the 9 over here, and I'm going to make this negative 9x minus 2y. And then I'm going to move the 27 over here and say equals negative 27. And then for this second equation, it's already in the format. They're just on the wrong sides. So I'm just going to put this negative 10x over here plus 10y equals a negative 30. So basically, I've just switched those back around. All right, so now what we're going to do is, now that we've got everything lined up, we're going to go ahead and try to eliminate one of our variables. Well, it looks like it's going to be easier to eliminate this one, since my signs are already opposite each other, and it's easy to just multiply 2 times 5, and that's what we're going to do. So we're going to multiply this whole top row by 5, and that way when we add our two lines together, the y's will drop out. Okay, so I multiplied the top row by 5, and I got negative 45x minus 10y equals negative 135. And then I just dropped this other equation back down here underneath it, lined everything up, and I went ahead and added these together. So here I got negative 55x equals, of course these drop out, that was the whole point, that's why it's called elimination. And then we're going to add these together and get negative 165. Now the last step to get x is just to divide both sides by negative 55. And when I did that, I got x equals 3. So I put it right up here in my ordered pair. I put my x as 3. Now what I'm going to do is solve for y, because I don't have y. So in order to find the solution for this, I need to find y. Although even though here it just says determine the x value. So read the instructions. These instructions say determine the value of x. Well, we did. We determined that x was 3. So really, we're done with this problem, because it's not even asking us for the y value. It's just asking us for the x. Now, if I wanted to find the solution, then I would also need to find the y. But it's not asking for that, so I'm just going to stop here. In the next problem, problem number 11, we're solving each 3-variable system by hand. And this time, I'm going to start with solving for y in this equation right here. So I'm just going to take this one variable at a time. So I'm going to solve for y here, and I get y equals, when I divide both sides by -4, I get that y equals 3. Now once I have y, I can solve for another variable in one of my other equations. Well, this equation right here has just x and y in it. So I know y is 3, so I can go ahead and make y 3 in that equation, and then I can go ahead and just solve for x. So I'm going to solve for x by subtracting 19 from both sides, and I get -16 equals -4x. And then when I divide by -4, I get 4 equals x, or x equals 4. So I know that my x is 4, my y is 3, and now I can solve for z. So I'm going to go into the next equation, this one up here, and I'm going to plug in my x and my y. I have 4 for x, I have 3 for y, and now I'm going to just solve for z. Okay, let's see. Let's add 3 to both sides. That gives us 7 equals -9 plus 4z. I'm going to add 9 to both sides. That's going to give me 16 equals 4z. And then when I divide by 4, I get z equals 4. So my set is that x is 4, y is 3, and z is 4. And that's my solution. Now remember what I said check and make sure that your solutions work. So I just want to double check it. So 3 equals -4 times 4 is 16. -16 plus 9 is 3. So that one checks. -4 times 3 is -12. That one checks. And then 4 equals -3 times 3, which is -9, plus 4 times 4, which is 16. -9 plus 16 is 7, and 7 minus 3 is 4, and that one also checks. So you always want to check your solution that you got, plug it back in to your original equations, and make sure they all check out. Each one has to check. All right, so for problem 14, I would like for you to change a couple numbers on here just because we want to make this work. We're going to go ahead and change the 8 on your sheet to a 6, and we're going to change the -14 to 13. That way this problem will work. I think what happened was we took one of the problems and changed some of the numbers and forgot to change some other numbers. But anyway, we'll just fix it this way. Just use the solution of 1, 6, and the equation should be x plus 2y equals 13. All right, so let's just double check this and make sure it works. 1 plus 2 times 6, which is 12, that equals 13. That checks. Now we want to see if this point works in one of these other equations that we have, so we just plug it in. So 1/3 times 6 plus 5/2 times 1 equals 7. Well, 1/3 times 6 is 2. So, and this is 5/2, which is 2 1/2. That does not equal 7. So we're going to say nope for A. B, 5 times 1 minus 2 times 6. Does that equal 2? Well, 5 minus 12 does not equal 2, so it's not B. Let's try C. 4/3. Let's move this over a little bit. 4/3 times y, which is 6, minus 2 equals 3 times 1. Is that true? Well, 4/3 of 6, that's going to be So 4/3 of 6 is 8, minus 2 does not equal 3. So it's not that one either. So we're going to look at one more equation, and hopefully this one will work. Y equals 2/3 x plus 16 over 3. Okay, so y is 6 equals 2/3 of 1 plus 16 over 3. Okay, well 6 equals 2/3 plus 16/3, which is 18/3, which does equal 6. So the answer is D. All right, so for a problem like number 16, we're going to graph these, the system of inequalities, and then we're going to look for points that would be solutions to this system. So the first thing I'm going to do is I'm going to rewrite my equations so that they're in slope-intercept form, because it'll be easier to graph that way. And then we will shade the graph based on where the solutions are. And then we're going to check a few points. All right, so first I subtracted an 11x from both sides, and I got negative 3y is greater than or equal to a negative 11x minus 24. Now, something happens right here when I divide by negative 3. I'm going to divide everything by negative 3, and it's really important to remember that when you're dividing an inequality by a negative number, the inequality sign flips over to the other direction. So that's real important to remember, because I noticed that on some of your homeworks, whenever you had an inequality sign flip over, you weren't doing that. And so you ended up shading in the wrong place. So that's what happens when you don't flip your inequality sign over. You end up shading in the wrong place. So you end up getting solutions that are not really solutions to your system. So again, you're always going to check your points anyway by plugging them back in, and that way you know whether or not that you've shaded in the right place. Okay, so this becomes 11/3 x plus 8. Okay. All right, so I have my two lines graphed. One of them is y is less than or equal to 11/3 x plus 8, and the other one is y is less than or equal to 1/3 x plus 2. So I've graphed both of those lines, and now I'm going to shade them. Well, since both of my inequalities flipped over to less than or equal to, it's equal to, so it's going to be a solid line, not dotted, and I'm going to be shading below on both of these graphs. So I'm going to use red for one color and blue for the other. So I'm going to shade below for this line. And then I'm also going to shade below for the other line, and I'm going to use a different color. This line here would be shaded below down here. Now where these two areas cross each other, right in here, this double shaded area is where all the solutions are located. So any point that I pick that's in this double shaded area, that's red and blue, will be a solution to my system of inequalities. And that also includes any points that are on the solid lines. Because since both of these were equal to, right here you can see this equal to, since they're both equal to, that means that any point on either one of the lines are also solutions to the system. So just make sure that when you're checking points, whether it's a solution or not, that you're plugging them back in and checking them. Like if I picked a point out here, I would plug that in, and I would find out very quickly that this point out here is not a solution to my system. Now, if I picked a point in here, it would be a solution to one of the inequalities, but not the other inequality. So what I need is points that are solutions to both inequalities. As long as it's a solution to both inequalities, then that solution is fine. That's a solution. But if it's not, then it's not. All right, for number 17, I'm writing an inequality system for this graph. All right, so we have two lines, and so what I need to do first is write the equation for the lines, and then I have to make sure that I've got the correct inequality symbol. Okay, so I'm going to start with my y-intercepts, and I'm going to do this dashed line first, and I see that my y-intercept is right here at positive 2. And I see that my slope looks like it's up 1 over 1, up 1 over 1. So I have a slope of 1. So my inequality is going to be y something x plus 2. And so the something that I'm going to have there depends on where it's shaded. Now it looks like it's shaded above this line. So if it's shaded above, then that's going to be greater than. And since it's a dashed line, it's not equal to. So I'm not going to put an equal to sign underneath my arrow right here, because that right here, I'm just going to leave this as a greater than, not equal to, because this is not equal to. Okay, so any point that's on this dotted line right here is not going to be a solution to my system of inequalities. Now I'm going to do the solid line, and this solid line has a y-intercept of negative 2. So this one's going to be minus 2. And its slope, let's see what its slope is. If I start here, I can go up 1, 2, 3, 4, 5. I would have to go up 5 units before I could go over 1. So this is going to be 5x. Now this one is also shaded above this line. And since it's shaded above, then I'm going to say that it is greater than, and this time equal to. So that's my inequality system. So I've written my inequality system for this graph. I can also check for solutions if I wanted to see which points would be solutions. Now remember, if you're checking points for solutions, that has to be a solution for both of the inequalities in order for it to be a solution for the system. Just don't forget about that, okay?